Hey kids, Dr. Runs here with your lesson for Objective 21. We have been making a transition from one topic to the next. We previously were in exponents, and then we kind of slid into scientific notation. And now that we know about scientific notation, we are going to learn how to do various operations with it, specifically addition, subtraction, multiplication, and division. We will start with addition and subtraction, which is typically the harder of the operations, and then go into multiplication and division. Okay, and in our normal lesson class, we had an illustration about money and counting up money, but this lesson is going to go long anyway, so I'm going to kind of skip over that illustration and get into the meat of our lesson. Okay, so each time we are going to add or subtract numbers that are in scientific notation or a mix of scientific notation and standard form. We are going to follow these same 4 steps. Step 1 is to write both of the values in scientific notation. So both values need to be in scientific notation. In this first example, they are already in scientific notation. A base times the power of 10. A base times the power of 10. The second step we will do is to adjust one of the expressions that are already in scientific notation so that both of the expressions are to the same power. So what I mean by that is, in this example, we have an exponent of 4 and an exponent of 5. And so what we will need to do is to adjust one or the other, it doesn't matter which, so that they either both have an exponent of 4 or they both have an exponent of 5. So let's just say I'm going to keep the exponent of 4. So I'm just going to bring this straight down, plus, give myself some space, and I want to do times 10 to the power of 4 on the right side. I'm going to zoom in because this gets awfully tiny. Okay. And then to adjust this, I need to consider if I am going from 5 to 4, am I increasing or decreasing by a power of 10? Well, 5 to 4 is a decrease, so I'll do the opposite on the left side. The opposite of a decrease is an increase by 1 power of 10. So this was 5.0. If I increase 5.0 by 1 power of 10, 5 times 10 is 50. So this expression and this expression have the same value, just this one is a different form, so that I can combine it with the first part of the problem. Okay. The next part is to add or subtract the first part of each expression. And when we do that, we are going to keep the base 10 the same. So we are going to add the first part, so 2 plus 50, and keep the base the same, just like so. And then finally, it says to adjust the solution so that it's in proper form for scientific notation. But do you know what I didn't do? I didn't finish, adding. 2 plus 50 is 52 times 10 to the power of 4. Okay, so now it's time for step 4. So this looks like it's in scientific notation, but remember, scientific notation is 1 digit, followed by a decimal, followed by the other non-zero digits. And I can't just bring the same thing down because I've just decreased by a power of 10. And similar to up here, if I decrease by a power of 10, then I have to increase by a power of 10. And so that is my solution. I have finished all 4 steps. Now, you don't necessarily have to do all 4 steps for each question. Sometimes you can skip them. Okay, so as we go in our lesson, so sorry. I will try to color code these steps as we go so you can kind of see a visual of how this goes. Maybe that's helpful to you. Okay. Also, I'm just gonna kind of plow right through here. I may suggest as we go that you pause and try this on your own and then play again to check for accuracy. But that doesn't mean that you can't stop other times or rewatch sometimes or, watch through multiple times to make sure that you understand what you are doing. Okay. Step 1 is to write both values in scientific notation. This is not in scientific notation. So this would be 4.0 times 10. Because this is a decimal, I know the exponent will be negative. 1, 2, 3, 4, negative 4. And we are going to add that, and this is already in scientific notation. Good. That part is done. Now we need to adjust so that I either have both negative 4 or both negative 7. And so I'm just going to keep this negative 4 so that this will also have to be something times 10 to the negative 4th. Okay. To go from negative 7 to negative 4, I'm going to increase by 3 powers of 10. It's kind of tricky because these are negative numbers, right? But if I'm counting up from negative 7, it'd be negative 7, negative 6, negative 5, negative 4, okay? So if I'm going to increase on this side by 3 powers of 4, then I need to decrease on the other side by 3 powers of 4. So I started with 3, and now I have to go down 3 powers of 10. 1, 2, 3, like so. So now I have 2 expressions with the same exponent, and I can do the next step, which is to add 4 plus 0.003 and keep the same base 10. And 4 plus 0.003 would be 4.003 times 10 to the negative 4th power. And finally, I need to adjust my solution so that it's in the correct form of scientific notation. This is already 1 digit followed by a decimal. So this is my final answer. Okay. All right, let's try one more addition and then we'll go on to subtraction. Okay. Step number 1, write both of these values in scientific notation. So 8 million in scientific notation is 8.0 times 10 to the 6th power. The decimal goes between 8 and 0. I'm going to count to the end of the number. 1, 2, 3, 4, 5, 6. Plus, this is already in scientific notation, so I do not need to convert that. Okay. Next, I will adjust so that they're either both 6 or both 8. I'm going to keep mine as a 6 plus something times 10 to the power of 6. And now I need to adjust. If I'm going from 8 to 6, that is a decrease of 2 multiples of 10. So to counteract that decrease of 2 multiples of 10, I need to increase. So I had 2.1. That's where the decimal was. And so I'm going to move 2 places to the right. And so 2.1 times 10 to the 8th power has the same value as 210 times 10 to the 6th power. And now I will add my values. 8 and 210 times 10 to the 6th, or 218 times 10 to the 6th. So that is the value of this addition problem, but it is not yet in the correct scientific notation form. Remember, the decimal goes between the first and second digits, so 2.18 times, and what now would our exponent be? I decreased by 2 powers of 10 between 218 and 2.18, so then I will increase the other sign by 2 powers of 10 to get 8. Okay, this is a tough skill. I don't want to undermine the potential frustration or difficulty in learning this. However, it is also something that does very much so get easier with time and practice. So I want to encourage you to keep at this. So this is kind of a quarter way through the lesson. Don't give up. Here's your little encouragement. Keep on going. Okay, again, just because it's subtraction does not mean the process is any different. So you guys have to see this. I've decided that she's going to set up shop on the worksheets. She's kind of a jerk. Okay, sorry. That was completely not related to what we were doing, and I sure hope I can get this set up again. Okay. Sorry, I probably should have just ignored that, but you know, we need a little excitement halfway through. Okay, so step number 1. Make sure that both expressions are in scientific notation. They are both in scientific notation. Step number 2. Make sure that both of the exponents are the same. In this case, both of the exponents are also the same. This is fabulous. Step number 3 is to do the subtraction. So 5 minus 2.5. 5 minus 2.5, keeping the same base 10. And so 5 minus 2.5 is 2.5 times 10 to the 5th power. And now the last step is to make sure that this is in proper scientific notation form. 1 digit followed by a decimal. We are good. Great. That one went pretty easy, didn't it? Well, they won't all be that easy, but we're going to enjoy it when that happens. Okay. Don't get frustrated. Stay engaged. You can do this. So this is, in scientific notation, 4.0 times 10 to the 1, 2, 3, 4, negative 4th minus 3.0 times 10 to the negative 7th. Okay. So now we need to get to one exponent or the other. So let's do these to the power of 7. So I'm going to leave my times 10 to the power of negative 7. Again, it doesn't matter what you do. I'm just choosing to do that. And so that means I need to set this up so that it is also 10 to the negative 7th power. So if I'm going from negative 4 to negative 7, I am decreasing by 3 powers of 10. So to compensate for that, then I need to increase by 3 powers of 10 on the left. So it was 4.0, 1, 2, 3. And so now it becomes 4,000 minus 3. 4,000 minus 3. And this is times 10 to the negative 7th power, or 3,997 times 10 to the negative 7th power. And so the last step is adjust this so that's in scientific notation. So 3.997. I just decreased by 3 powers of 10, so let's increase by 3 powers of 10 on the opposite side. And that's our solution. Okay, here we go with one more fabulous subtraction problem. We've got this. Step 1, Make sure I hope this is getting repetitious. This is the 6th time we've gone through the same process. It's never going to change. So make sure that both are in scientific notation. This is not. It would be 6.0 times 10 to the 7th. That's right. The decimal goes between 6 and 0. 1, 2, 3, 4, 5, 6, 7. Now that it is all in scientific notation, now I have to adjust the exponents so that they're either both 8 or both 7. And so this time I want them both to be to the power of 7. No particular reason, just felt like it. So now I want to set up the left side so that it is also to the power of 7. So if I go from 8 to 7, that's a decrease. So this side I need to increase by 1 multiple of 10. So 9.8 times 10 is 98. Now that I both have times 10 to the power of 7, I can subtract 98 minus 6 times 10 to the power of 7, or 92 times 10 to the power of 7. And last but not least, adjust so that this is in scientific notation. Decrease this, increase that. Right? 92 to 9.2 is a decrease by a power of 10. 10 to the power of 7, 10 to the power of 8 is a difference of 1 multiple of 10. All right. Before you switch, I want to encourage you to just take a minute, stop and look at what you've written. Consider if you understand what you're doing between each of your steps. And perhaps consider going back and rewatching if you need to. But then keep on trudging through if you're in a good place. Okay, so we are on to multiplication and division, and the process is almost identical, but simpler. So we are still going to start with writing both values in scientific notation. But, oh, this is such a relief. We no longer have to adjust the exponents so that they are the same. It won't make any difference anymore. And then, because this is multiplication and division, we will either multiply or divide, whatever we're being asked to do. The first time of having a hard time talking, this first part of the expression, and then we are going to multiply the second part of the expression. This is the new part this time. And then, of course, we're going to adjust this so that it is in scientific notation form again. Let's jump in. Apologize for going fast, but I see this video is getting long already, so I want to make sure that I keep this going for you. Okay, step number 1 is to make sure that both of these values are in scientific notation, and they are, so we can be done with that. We do not need to adjust so that these are the same exponent. It doesn't matter. We're just going to deal with them later, so that part's done. Step number 3 is to multiply, because this is multiplication, the first part of each expression, 6 times 9. And then we are going to multiply the second part of each expression, 10 to the negative first times 10 squared. So we're multiplying these two together and then multiplying these two together. 6 times 9 is 54 times 10 to the power of. Now remember, when we are multiplying the same base, we do what with the exponents? We add the exponents. So negative 1 plus 2 is 1, or 2 minus 1 is 1. And then finally, adjust so that we are in scientific notation. 54 goes to 5.4. That's a reduction, so we're going to increase the other side by a power of 10. And that is our solution. 6 times 10 to the negative first times 9 times 10 squared is 5.4 times 10 squared. Another way of saying that is 0.6 times 900 would be 540. Kind of cool, huh? Okay, here we go. keep on going. Feel free to go a step ahead of me though. Write both values in scientific notation. So this would be 7.0 times 10 to what power? 1, 2, 3, 4, 5, 6, 7 times 3.0 times 10 to the 6th. Notice in this problem I have a multiplication x, and in the previous one I did not. Remember, when two sets of parentheses are together, that implies multiplication. Okay, and so now we will multiply the first part of each expression, so 7 times 3, and then the second part. 10 to the 7th times 10 to the 6th. 7 times 3 is 21 times 10 to the, this means 10 times itself 7 times, this means 10 times itself 6 times, so altogether it's going to be 10 times itself 13 times. And the way that we would figure that is to add the exponents. 7 and 6 make 13. And then finally, this would be 2.1 times 10 to the what? 10 to the 14th. Great. Good. 70 million times 3 million is 2.1 times 10 to the 14th. Here we go. One last multiplication one, and then we can start division. So step 1 is to write this in scientific notation. This is a decimal, so I'll have a negative exponent on my 10. 1, 2, 3, 4, 5, 6 times 4.0 times 10 to the negative third. Great. It's nice that I don't have to convert those exponents. I'm just going to skip that step and be thankful. And then do 5 times 4 and 10 to the negative 6th times 10 to the negative third. We're combining this part and then this part. Okay, 5 times 4 is 20 times 10 to the negative 6 and negative 3 are negative 9. Okay, and then it becomes 2.0 times 10 to the, this is a decrease, and what is an increase from negative 9? It's tricky, it's negative, so it's negative 8. Okay, and there we go. Okay, and that wraps up multiplication, and now we have only division left. Okay, division is the same exact procedure as multiplication, it just happens to be division. So step 1, again, this should be so repetitious at this point. Hopefully you're getting tired of hearing me say these steps over and over and over again, because you're starting to commit it to memory and you don't need me so much anymore. Okay, make sure they're both in scientific notation, and they are. They don't need to be the same exponent, and I am so glad for that. So that is that. And so now we're going to do the first part. This is division, so it'll be 8 divided by 2, and then 10 to the 6th divided by 10 squared. 8 divided by 2 is 4. Now, if you remember, if I'm dividing the same base, it might become more familiar if I write it like this. This is how we've seen it before. So same base, and we'll subtract the exponent, because in this 10 to the power of 6, 2 of those powers of 10 are going to cancel out, and we'll be left with 4 powers of 10. 6 minus 2 is 4. And then write this in proper scientific notation. 4.0 times 10 to the 4th. I didn't change that value. I just added the 0.0. You should always have one digit after the decimal, even if it's just 0. Okay, now sometimes division is vertical. That one was a horizontal example. The process is just the same. Step 1, is it all in scientific notation? Yes. Step 2, don't have to do it. I'm thrilled about that. Step 3, see how in the previous step we handled this and this? In this example, it's like dealing with the left and the right. 9 over 3 times 10 to the 7th over 10 to the 13th. We handle it in pieces. 9 divided by 3 is 3 times 10. 7 minus 13 is -6. Now, in previous lessons, you've learned that if you have an exponent that is negative, that you should write it with a positive exponent. Scientific notation is a rule breaker. You do not need to do that. But you do need to change this to 3.0 times 10 to the -6. Because there's no value difference between 3 and 3.0, I do not have to adjust the exponent. And finally, we have arrived at the last one. Thank goodness. Okay, step 1, write this in scientific notation. So that is true in the numerator, but not in the denominator. Wah, wah. So this would be 5. Oops, sorry guys. This should be a 2. Typo. I'm sorry. 2. Once in a while, there is an error in my worksheets. Most of them have been fixed, but once in a while, good thing I have my other notes here. Okay, so I'm going to put my decimal here. 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the power of 8. I do not need to convert them so that they are the same. So now I will divide 7 over 2 and multiply that with the result of 10 to the 11th over 10 to the 8th. 7 halves is the same as 3 1/2, or 7 divided by 2 is 3 1/2 times 10. 11 minus 8 is 3. And that's in scientific notation. Ah, rats. I should have done that in purple because I was doing that third step still. I was doing the division part. The fourth step, is to make sure it's in scientific notation. Okay. There's an important part question for you to consider. We'll do it in class, but again, since we're coming up on a half hour in this lesson, I'm going to keep on going. But of course, you're very welcome to ask more questions in class. That always makes me happy when kids ask questions. Okay, so your homework assignment is a mix of all of these operations. So there are 1, 2, 3 addition problems, 1, 2, 3 subtraction problems, 1, 2, 3 multiplication problems, and 1, 2, 3 division problems. And so when I wrote your notes for you, I did so that you would have an example of every type of problem to follow. So for example, this is addition, 2 numbers that are already in scientific notation. So you can look in your notes and find an addition problem that has 2 numbers already in scientific notation. This is let's pick a different one. This is a subtraction problem that has standard form minus scientific notation. Well, we did one of those. We had standard form minus scientific notation. So those notes have been written to help you. Now, I want to specify here that I would like for you to do this without a calculator and to show your work, because I am not, pardon me, stupid, but I know that you can do these using a calculator. It's important, though, that you know what you are doing and that you can show your work for this. And so you are very welcome to check your work with a calculator. In fact, you are encouraged to do so. But please do not do the work solely with a calculator. And this is why I ask you to show your work, not just to prove that, but if something goes wrong in the process, I can help identify some problems with you and reteach you more effectively because I can see where your misunderstandings are. This is a tough thing, so I recommend that you take it in pieces. Of course, feel free to bring those pieces to me occasionally to check for accuracy if you would like. Again, you can check your work with a calculator. If you are stuck and need some help, please do not hesitate to send me a message at this address. And I did not do my disclaimer at the beginning like I normally do. But of course, this isn't the most thorough, complete, amazing, earth-shattering lesson on operations and scientific notation, but it is a short recap of what we did in class, just the basics to get you going. And of course, you always know where to find me in case you need some additional help. I hope that was helpful. Thanks, guys, and I'll see you in class. Bye.